Lucia, for facilitating this opportunity for me to be able to join. And thank you very much to your wonderful team for the invitation last year. I think it's a great opportunity to be here, and I don't take it lightly at all. I want to also apologize for the time that we've started now. I think uh, we're still going to get the best out of what has been packaged for us. So without much ado, let me share my screen. I think I should be excellent. Right, so let me pull this up. Can you see my screen?
Yes, we can, sir. Thank you, sir.
Excellent, thank you. I hope it's in full screen mode. Brilliant.
Yes, it
I
is.
think, thank you. I think the topic is very timely and also significant. I would like to um, probably just say as a caveat, I am not actually an AI expert, but I use AI. So that would be the caveat for that for now. And I use AI in our research, in our education, in our teaching, and of course in other areas of our work, uh, both in the academia and outside. So I've been asked to speak on leveraging artificial intelligence for advancements in agricultural and scientific research in Nigeria. Of course, we all know that artificial intelligence is obviously driving not just research, innovation, and probably governance, but of course, looking at the global landscape today, data have become, I would say, premium resource. So, and with the development of advanced semiconductor devices that can literally, carry out computations in no time. The latency is literally reduced to, nanoseconds, and probably literally within a twinkle of an eye, you have data analysis or data output being completely processed and information delivered in no time. And with advanced radio access technologies, the entire global economy and the entire global, I would say, governance population is sort of enveloped in this ecosystem of data analytics and data driven intelligent decision making. And it's not good that anybody should be left behind. And I'm really, really glad that we have people in the sub-Saharan Africa, especially in Nigeria, being able to come up with this kind of seminar or webinar where people are enlightened and we have opportunity to share for mutual benefit. So kudos to the organizing committee. And once again, thank you for welcoming me and appreciating my insight and expertise in this area. So by way of looking at the outline that I'm going to use for today, this afternoon in particular, I'll first of all talk about the background of our research and our industry-linked research, innovation, and development engineering at the Manchester Bay University. I will also move on to speak on the AI fundamentals, so artificial intelligence fundamentals, some basic concepts around artificial intelligence. And then we consider the AI techniques and tools that are available, been developed, existing, emerging, and probably future ones. And we also will consider AI platforms and practical skills. And we'll conclude this webinar by looking at the collaboration opportunities, and then we see where we go next. Right. As I did mention before, we are a leading research team globally. We work with world leading companies, but we develop hardware. We are not really a software kind of research team. We actually develop products. So it does not matter the sector, whether it's in wireless, wireline communication, manufacturing, industry 4.0, energy, water resources, fashion, and supply chain, agriculture, healthcare, transportation, sustainable infrastructure, space, aerospace, environmental monitoring. We have our niche fully protected in this sector. So, and we work with world-leading companies using advanced process technologies to develop subsystems for the mobile phones, home electronics, industrial electronics, and of course, smart farming and precision agriculture, developing Internet of Things sensors that can be embedded in the soil for soil mechanics determination and also for precision agriculture practices. And some of our development and some of our designs have been actually embedded in chips. So we develop chips using some advanced design techniques, such as monolithic microwave integrated circuits and passive integrated devices. So all of those we kind of cover in our research team. And in front of you are the chips that we've designed. I personally designed this chip, which is for satellite CubeSat applications and all this also for satellite television applications. In our research team, we also develop biosensors and also fiber integrated reception systems. Currently working holographic beamforming that could be applicable in smart agriculture, especially when you look at passive and active sensors and sensing, which could use energy from the roots of the plant. And some of our industry partners, both in the academia, industry partners that work with us, and also industry partners that work with our third-party collaborators. So we have partnership with the industry, partnership with the academia, and it's not just in the global north, but also in the global south. We work with some of our universities, partners in Nigeria, as well as in the, Europe and US and other places. And in terms of research, as I mentioned before, we obviously embrace an integrated research kind of ecosystem where the students that work with us, they also are educated in the disciplines of our research and exposed to the opportunities we have as academics and of course researchers, research active academics. And this has really created a very healthy community of researchers where our students are taught and also exposed to advanced technologies because obviously we expect our students to definitely come and know more than we do because the future belongs to them. So, and as you can see, these are some of the members of our research team. Some of them have graduated, some of them are working in the industries now. And as I mentioned before as well, we've got some very, very embedded sort of philosophies around research and also around teaching. And whatever we do, we try to ensure that the visibility of our work in terms of impact, in terms of applications, use cases, help to solve societal problems. So impactful research with excellent education. Right, let's move straight to the AI fundamentals, just focusing on the main reason why we are here. I would probably want to ask, what is AI? When you hear of artificial intelligence, what comes to your mind? Do you think of artificial intelligence as something very advanced, very complex, or something that is just beyond your ability to comprehend? Well, I would say artificial intelligence is just a method or technique that enables machines to reproduce human intelligence, not replace human intelligence. Because human intelligence can be cursive. So when I say cursive, because obviously artificial intelligence would depend on what you put into the machine, what you enable the machine, what you give to the machine. But human intelligence, divine intelligence, I would call it, it's an intelligence that can recreate, regenerate itself. And with AI, especially moving towards generative AI, which we'll soon look into, machines are trying to get to the ability to sort of create knowledge that didn't exist. But of course, they are limited by the knowledge they already have, because depending on what the machine is exposed to, so machine will try to make some inference. And that is where we have the process in terms of process life cycle for artificial intelligence. And we sort of start with data. Now, data processing, data is, when I say data, picture it as raw data, because when you process the data, it becomes information. So raw data pre-processing is the first stage of the AI process. So the machine wants to reproduce human intelligence. The machine definitely will have more capacity than the human brain in terms of storage, in terms of resources, because you can have, advanced processors like field programmable gate array, which can parallel sort of undergo or implement parallel processing of data. And that helps to process large data sets, which with a limited human brain storage capacity, it would be difficult to process such a massive, probably um, data set from different sensors coming from different places. And of course, in different forms, could be video, could be motion picture, could be voice, could be, just ordinary data like numbers, quantitative or qualitative. However, we still need to have data pre-processing, and model training follows the AI process lifecycle. And because model training follows, we have to find a way of testing the models that the outcome of this model that we've actually trained to understand the data, and then use the data to make an intelligent decision. And then finally, we have to deploy, because we won't just test something without having a place to deploy it. Sorry. So the deployment is where we test to see whether our model actually is doing exactly what we would like it to do in real life. So the testing is more like a simulation, which we can actually do some simulation in the lab. And then we obviously use some advanced resources in terms of computational resources. So it could be computing resources, which we can develop distributed computing, edge computing, or parallel computing. But on the whole, we will need to model train the model that we've got using the data we have, and then we need to test and then deploy. There are many use cases when we consider AI fundamentals, and this diagram just shows the various areas or use cases where we can actually deploy artificial intelligence, especially where the infrastructure or probably the operation is critical. And I want to focus on smart agriculture. So you might see here, you kind of witness the smart farming or precision agriculture, as the case may be. So here we might have a large acre of um, land, and we want to sort of plant some crops and sow some seeds, or even harvest the crops. So we might obviously need to irrigate, might need to check for disease condition, or we might want to investigate the soil mechanics of the place. So AI will enable us to do all the things that probably it would take so many people to handle and even process, and it might take more time, might not be cost effective, and of course can affect productivity in the end and the yield. So in this case, we can deploy machines that are intelligent, that are smart, that are also able to enabled us make intelligent decisions remotely and on site. So in situ decision making. And smart farming definitely is one of the key areas or use cases where AI can be applied. Of course, there are other use cases, as you would see on the screen there: predictive maintenance, supply chain management, cybersecurity, healthcare, inventory management. So name them. So many areas: data analysis, dynamic pricing, we have quality assurance. So if you look at education, automation, forecasting, especially in weather condition forecasting, finance, chatbots in the finance sector, and data management, and so many other use cases, customer service. So you can even create a use case yourself, depending on what you want artificial intelligence algorithms to do for you. And in terms of application, of course, within the use cases, you've got different applications. So nowadays we have virtual assistants, we have recommendation systems, we have fraud detection systems, we have autonomous vehicles. So in terms of the automotive sector, I mentioned healthcare before, in medical diagnosis, drug discovery, retail, finance, neural language, and natural languages that have been developed, processed for chatbots. Other applications also in the area of education, where you have personalized learning experiences and ability to provide feedback to students using AI-powered tools in the entertainment industry, manufacturing, um, smart home, cybersecurity, marketing, transportation. So these are different applications where we still find AI playing a key role. And I've got here a wall of IoTs, where, of course, within this wall of Internet of Things, so IoT means Internet of Things, within the industrial sector, we have agriculture. So the industrial sector is here, and here we have agriculture. And of course, at the top hierarchy of it, where we have smart farming, precision agriculture, we still need AI to make the sensors smart, to give intelligence to the sensors. Of course, the sensor will gather data at the edge, and then the data will be sent to the gateway. From the gateway, it gets to the enterprise. The data could also be processed. So that's what we call edge AI. And with the processing, we can actually be able to have intelligent decisions coming out of the data that have been processed. So many sectors, as you might see in this diagram in front of us, and it tells us that with the advent or the emergence of artificial intelligence, quite a lot can be done, and efficiency, productivity can be greatly enhanced, and opportunities abound for everyone to do something novel. And of course, when one processes a data, or rather processes data, when one processes data and the data needs to be relayed, needs to be communicated to a particular location, you need the infrastructure to do this. So there's no point processing a data, or rather processing data, but you cannot actually use the data. So we have different wireless technologies that enable data processing and data transmission, data communication to be possible. So from proximity technology, wireless personal area networks, wireless local area networks, wireless neighborhood area network, and of course, wireless wide area network. I'll just probably pick one of them and think about having a wearable for the sheep or goats or, cattle, whatever type of animal we might be rearing. And we ensure that these animals, they have wearables on them, we tag them, and we can actually monitor their health, monitor how far they go in the field remotely. You don't need to be physically present. Or we can send a drone to communicate with the animals, at the field, wherever they are, at the farm. And technologies have been developed, so wearables that can actually enable this to happen. And those animals can actually be guided using artificial intelligence or AI-enabled sensors, just like a human would be there to guide them to watering or guide them to feed somewhere. So AI robots can actually be sent to do those jobs and also look after the welfare of the animals. And in that case, if it were to be something that would probably enhance productivity or help remote monitoring, could even be in the night, in terms of security and safety. So AI-enabled robots can be sent at midnight to go and monitor the flocks or go and check whether they are healthy, and they can be programmed to do so. Of course, when you are resting, the AI can actually go in the night to check what is the state of the flock or the health of the animals. And these are areas that we can actually apply these technologies. In terms of 5G technologies, of course, long-range communication. So we can integrate mobile communication into the smart farming or precision agriculture ecosystem. And that is where we have wireless wide area network. And integrating artificial intelligence into it would obviously become a game changer when it comes to enabling these applications to actually take effect. So having said that, I would like us to probably consider the aspect that has to do with the operational constraint in terms of computation of the data that AI would probably be working on. So we have some auxiliary computing technologies that enable AI to function. So distributed computing, edge computing, and parallel computing. Nowadays, we have what we call tiny machine learning, which obviously we expect the algorithms to consume very low power, less power than conventional algorithms. And that would enable ultra low carbon deployment of AI models, which can then make intelligent decisions, sometimes even passively without needing a battery, so battery-less systems. And they can actually take energy either from the environment in terms of solar or energy that are directed to them over the air, so what we call OTA transmissions, over the air transmissions to the sensors, and they are running the edge artificial intelligence capabilities and hardware functionalities, and then be able to transmit the data back to the beacons, communication beacons that are mounted at the farm, and that would then be sent to the cloud or transmitted remotely within any local area network that have been set up around the farmhouse. So in this context, of course, 5G and 6G will be working together, linked up to satellite in terms of next generation connectivity ecosystem. So that's what we call satellite cellular convergence ecosystem. And at the top of it will be pervasive AI, which you might see here at the top of the 6G communication flow. Looking at about 2030, when this will be rolled out. A lot of research going on at the moment. And of course, smart farming, precision agriculture is not left out as a key use case where this technology will be deployed. And there are other use cases that we have, which we sort of can deploy AI, so AI-based wireless connectivity use cases in terms of smart home, wearables, smart city, factory automation, smart energy, connected car, smart farming, precision agriculture. So the list, is literally endless in terms of AI-enabled wireless connectivity use cases. And they are all enabled by the third phase of the internet revolution, which we call Internet of Things. And it's important to note that no one or no single wireless technology can provide the connectivity that we need. So we need a mix of all of them. Yeah. So another key area, of course, I've already mentioned this in passing in terms of livestock monitoring, where we have livestock management, horticulture automation, crop monitoring, farm equipment monitoring, smart sprinklers, solar farming. So all areas where AI and wireless communication applications would be, game changing or game changers, as the case may be, in smart agriculture. And this infrastructure would have to be made available for enhanced productivity, enhanced crop yield, and of course, in terms of bringing more income to the farmers. And every government is investing heavily to ensure that there is food security. And of course, with the work that NIWAD is doing, is telling kind of initiative in the right direction. And other areas we've talked about real-time monitoring. So not just monitoring in non-real time, we can have real-time monitoring. And we also can have increased operational efficiency, cost reduction, because with intelligence brought into bear, you can reduce waste. So waste is not just the conventional waste. Data, if you don't use the data you've got to make intelligent decisions, so that would be a huge waste. And with AI, data can definitely be converted into wealth, for the relevant farmers and other stakeholders, improve resource management and sustainability definitely would be ensured. And of course, with the system become more scalable, you can literally harvest to meet the demand. So you don't just harvest endlessly or harvest without having something to benchmark the processing of the crops or processing of the farm produce. So in this case, we will see later an example of what we are working on in our research team, and there will also be the aspect of increased productivity. So a typical network that uses AI-enabled kind of infrastructure is shown in front of us. So you have the low-powered mesh sensor network involving the sheep and other farming entities and nodes. And there's a gateway here. All of these entities here, they have connectivity nodes, and they are all linked up to the gateway, which has a protocol that enables it to ship the data. So in this case, we're using the Wi-Fi technology. And currently, within the Wi-Fi technology or protocol stack ecosystem, we have Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, Wi-Fi 6E, and Wi-Fi 7. And of course, the higher the standard, the more data you can pump through the network. And of course, if you recall the other diagram I shared with us previously, in terms of proximity technology, in terms of personal area network, wireless area network, wireless neighborhood area network. So for the wireless local area network, that is where the Wi-Fi technology sits. And that can be created within the farm and is AI enabled. And the data can then be sent to the farmer or end user. And of course, aspect of low data connection where the data processing or the requirement is not very critical in terms of the state of the farm equipment can also be Bluetooth using a protocol called Bluetooth or Bluetooth Low Energy to the farmer as well. But within the ecosystem of the smart farming, you can have an integrated connectivity that is empowered or powered by artificial intelligence to enable intelligent decision making. And that would give the farmer peace of mind. What are the AI techniques and tools that are available? Again, it's not important or compulsory, it's not mandatory that the farmer should know much about AI techniques. These techniques are available, the tools are available, and everybody can use these tools. So, but just for the sake of knowledge, just to help us understand the underlying principles or techniques in terms of the taxonomy of artificial intelligence. So I'll just give us a very fundamental insight. So within the artificial intelligence, as you could see in the diagram we have here, you look at the taxonomy of artificial intelligence, you've got the machine learning as a subset of artificial intelligence. And within the machine learning, you now have, we have there's what we call spiking neural networks, and which is within the brain inspired. And we also have the neural networks. But within the neural networks, we have the deep learning. Don't worry, I will explain what each of these, what they represent and what sort of delineates one approach from the other. And then within the deep learning, you have the generative AI, which I will shortly share with us. And as we consider the taxonomy of artificial intelligence, we can literally group this taxonomy into two. So in terms of the physical and medium access control layer, which has to do with the physical wiring and cabling, whether it is free space transmission of AI processed data or model data, or it has to do with network layer. So depending obviously on the application, the learning method and the tools used, we can actually have different AI techniques operating across the what we call the OSI model of the communication infrastructure or communication protocol stack. So in this case, we have both the physical layer and the medium access layer or the data link layer, and we also have the network layer. Of course, these are invisible to the human because they all happen within the machines. And that is why the intelligence is sort of coded onto the machines to mimic human intelligence. So coming to generative AI, as I mentioned before, I'm sure we are all used to ChatGPT now. So the artificial intelligence has to do with robotics kind of operations. But when you look at chatbots, the chatbots, we all use chatbots sometimes. You have companies using chatbots to sort of respond to customers. So that way you have the machine learning. But ChatGPT is where you bring some cognitive capabilities to the deep learning output or deep learning heuristics around generative AI. And of course, ChatGPT is an example of a generative AI. And we'll see more about what the generative AI does, especially in the context of research, grant writing, presentations, and other areas where we might want to consider the application of the AI techniques. So what are the AI tools? As I mentioned before, machine learning. When we look at machine learning or AI, machines carry out tasks in ways that humans might consider smart or intelligent. And what machine learning, which is a subset of artificial intelligence, would focus on the algorithms that actually that can learn from data provided. So if the data is not correct, obviously the algorithm will be working on a premise of a wrong data, or rather wrong data sets. So in that case, it's important to make sure that the quality of the data, whether it has to do with the health of the animals or in terms of crop yield or in terms of the soil mechanics, the sensors deployed, the data that the AI needs to work on, the model needs to be trained with, must be the correct data, because that will affect the intelligence that the system will be able to deliver. So when you look at the output from the system, the impact of that output will now become an outcome. So obviously, data quality is very, very important in this context. So deep learning would then constitute a subset of machine learning. So deep learning uses neural networks with many layers to sort of deep neural networks. And they learn and make decisions based again on the data. So the data quality is very, very important, because without data, literally, the artificial intelligence is non-existent. It's like it would be like a body without the soul. So in that case, we cannot have artificial intelligence as an application or an innovation, an auxiliary technology that can offer any use to us. So, but generative AI, which is the next frontier, as I mentioned before, is a subset of deep learning, and machines with versatile cognitive abilities can actually understand, learn, and apply knowledge pretty similar to humans. But of course, remember, they are not really causal. Or causal. They are not causal. I think that would be a better term to use. But they depend on the data you feed into the system or the data they learn from. And they can apply knowledge across different domains. And that is why generative AI, example, the ChatGPT, is very much used and is finding application in a very pervasive way in recent times. So all AI sets would provide the setting stage for the entire application of intelligence or smart implementation. And machine learning would then refine it with data-driven insights. Then deep learning would add capability and complexity with deep neural networks. And the generative AI would then provide the capability around cognitive understanding. And as we see, a typical tool workflow for AI will comprise of data preparation. As we see in front of us, so there's the aspect of data preparation, and of course the AI modeling. So we talked about model training, simulation and test, and then deployment. Because within the data preparation, again, data cleansing and preparation. So data quality, very important. So quality of data we obtain from the farm, obtain from animals, from crops. If it's about crop disease monitoring and using AI to probably apply whatever chemicals we need to use for the treatment of the crops, or in terms of soil mechanics, or in terms of irrigation in every region or where we find that the plants are not really performing, growing as they ought to. So with sensors buried in the ground, we can get information on the humidity, temperature, and pressure and other parameters that will enable us to better understand the growth rate or growth profile of the plants over time. And that can also help with our ability to obviously make intelligent decisions on this. So model design and tuning. So in terms of the model testing or model training rather, we have hardware accelerated training, have interoperability. In terms of the simulation, we want to simulate the system simulation would help us to make some predictions before the deployment. So we integrate with complex systems or system of systems, and we also carry out system verification and validation before final deployment. So you can think of it as having a hierarchy that is a three-stage hierarchy: age, gateway, and then enterprise. And of course, in the end, you want to be able to have the deployment done without much ado. We talk about AI and we cannot stop talking about data. And there are many data sets, as we would see. So the types of data sets can have tabular data, time series or text data, or image data. So depending on the type of data, machine learning would always be used for tabular data driven kind of part of time series text data. And of course, when it comes to image data, deep learning techniques would be more applicable. But of course, as you can see, there are many AI models that have been developed, and of course, approaches and techniques, as we've already looked into in passing. So with the type of data you've got, depending on whether you took a picture of the animals or took a picture of the crops or plants, you can deploy or you can use a particular type of AI technique to predict what happened or the type of food. So you can actually harvest fruits, or you can take a picture of the fruits. And if you want to know whether they are ripe to have for harvesting, just take a picture and then you can map that into your AI model. And AI will predict whether it is time to harvest the fruits or the crops or not. And you can map that to the market demand as well. And that helps us to have a kind of a holistic, smart and intelligent precision agriculture ecosystem. As already mentioned, AI is a familiar feature of many digital tools for a while now, and generative AI has emerged as a topic of interest, and there are also concerns as well. So some of us, I'm sure you've used ChatGPT before. We'll do a bit of an activity at some point. So if you can type this link on your browser, if you're using a mobile phone or you're using laptop or any other device that is connected to the internet, if you've never used an AI platform online before, don't worry. It's very straightforward. It's something that we can easily do together. So if you just type this link that is displayed before us, https://gptonline.ai/chatgpt-online/. So if you type that link on your browser, you should be able to type anything you want to type and ask the AI anything you want to ask the AI, and obviously it's going to produce some result. But remember, AI depends on what is in the database to make predictions. Of course, it's going to try to comb everywhere on the internet to see where it can get information to sort of respond to your questions or respond to your comments or request whatever you want the AI to do. And because we are using ChatGPT, ChatGPT is a subset of deep learning, so generative AI. Example of generative AI is ChatGPT, and it's a subset of deep learning. It means even if you put a picture, it should be able to provide some information about that picture because of the cognitive capability and working on large data set models that have been made available to it. So generative AI has gained popularity since the release of generative, pre-trained transformers, so the GPT. And today we can use ChatGPT as a powerful tool that enables researchers to propose novel research ideas, write code and novel textual content, manage data by analyzing and synthesizing large volumes of information. And of course, in terms of latency, in terms of speed, in terms of accuracy, you're likely to have better output than human would do. But that doesn't make the AI to be causal. Remember, the AI is not causal. AI depends on the data that it has been trained with. So it can also improve the quality of writing, probably you're writing a grant or writing a report, you can use AI to improve the quality of writing, identify potential errors, inconsistencies, even grammar corrections, and the logic of what you want to actually convey to make sense to the reader or the receiver. So AI ChatGPT is very, very good. And there are some AI tools for research, manuscript writing, and grant writing. So in terms of literature search and review, you can use ChatGPT. It's very, very common. It's a generative AI. And you also have the Elicit, Scholastic, Consensus. These are other types, but common ones are available. There's also the lead maps, which enables us to actually, we are doing a research or you're researching for a particular topic. Not only will it provide content for you to review, also gives you information about the authors and the links to those contents, and you can actually do more systematic review of the work that you are trying to develop. So there are also AI tools for planning and study design. And here we still find generative AI being very useful. And as we can see, we also have AI tools for data collection, visualization, interpretation, and reporting. There are tools for manuscript preparation, but you've got to observe the ethical principles around openness, honesty, transparency, efficient use of resources, and of course, fake allocation of credit when it comes to referencing and citation while using AI, because there's got to, sometimes they might ask you to disclose the use of AI in manuscript preparation. There's also the aspect of AI tools for peer review assistance. One thing that we need to also think about is the auto, what we call auto peer review. It's not very good to consider or probably want to use AI for auto peer review where there is the tendency for bias. But we can use AI when it has to do with performing initial quality control for submitted manuscripts. And of course, it can suggest appropriate journals and venues for an article. Definitely, that would be a good way to use AI. AI tools also for grant writing. We've got Grantable. We have Google AutoML for data analysis platform. And in terms of presentation report or support, the Toom AI. So there are many tools that are available that we can use to enhance our research, enhance our learning and teaching or education, enhance our innovation. Of course, even in practical applications where you actually want to deploy AI in your smart farming or precision agriculture. There are companies and organizations, and of course, whether in the industry or in the academia, we can collaborate and partner with to have AI integrated into our operations. So, what do we think are the pros and cons of AI tool for literature review? I would like it to be a bit interactive. So you can put it on the chat. You can type on the chat, what do you think are the pros and cons of AI tools for literature review based on the presentation? Dr. Bildung, if you don't mind to check the chat to read to me what colleagues, people have typed on the chat, meeting chats. What do we think?
I will do that. I will do that as we start saying. Thank you. Okay, somebody is saying it can give you wrong citations that
Brilliant.
do not exist.
Brilliant. Brilliant. So that is, would we say that is a con? That is a con. So what about
Yes.
a pro?
Pros.
We can type more pros and cons of using AI tools for literature review.
Okay. For some of the pros, we have it is very fast in
Great.
generating ideas.
Great.
Then it helps productivity.
Good.
It can help you get useful literature. It can help you summarize literature.
Great.
So those are some of the pros. Then, okay, somebody is also saying it increases accuracy.
Excellent.
Yeah.
Excellent. So, of course, that is true. Those are good comments and well done. Definitely, those are very valid comments and very valid points in terms of the pros and the cons when it comes to using AI for literature review. Uh, so, the time and resource efficiency, higher writing standard, higher quality in terms of research insight, personalized assistance. But you also need to be careful and to consider the aspect of originality. Because if AI is pulling something that has not been peer reviewed and a person uses the data or uses that information to make decisions, that could be very misleading. Think about probably designing something for a critical application or healthcare application, and one has not checked the source of the information. And if that is then used in drug manufacturing or something that would impact health or the health of the animals, as the case may be, that could be dangerous. So imagine AI, probably one needs information on how to handle the health challenge of a particular animal at the farm, and then AI shows up with a recommendation that is poisonous. So if the individual takes that and gives to the animal, the flocks will die. So it's important to check and sort of confirm the originality of AI generated content. There are also aspects of ethical concerns, especially regarding intellectual property rights. So again, AI might just pull things up, but we need to obviously ensure that we acknowledge, give credit to the innovators or inventors or discoverers, the owners of the source of the information. Uh-huh. So, and the aspect of a lack of nuanced kind of understanding, because AI, because they are not human. So it's important to understand the non-causality of AI, and of course the risk of hallucination around what AI is actually sharing with us. So what about manuscript preparation? What are the pros and cons? Reference,
Cited is not reliable.
right? Yeah, and make no mistake, we see this a lot with students. Students just generate all sorts, and the references are not linked to the project or the report, the coursework they are working on. And that in itself is a misconduct, an academic misconduct. You shouldn't just generate things. There's no originality. And
Yeah.
so we find that a lot with students probably leaving their coursework or projects to the last minute, and they just put everything on ChatGPT, things come up, and they just cut them and would paste them and feel that they've finished, and then they submit. So those things can be very misleading. Yeah, definitely.
Yeah. Then we also have it encourages excessive dependency. Then
Exactly. That's
yeah,
correct.
it takes away originality. You've also mentioned
Exactly.
that. Yeah.
Brilliant. Because obviously the human brain, we train our brain by using our brain. We make our brains to be smarter and intelligent by engaging our brain. So where AI is replacing this, before the art of writing is lost. Sometimes AI would obviously try to understand what is in the brain, but cannot completely comprehend the thought process, the way you might want the paper, the concept, the ideation would be missing because it is handled by a machine that is based on data or information that it has. Okay.
Maybe I can also read this, though lengthy. It said a couple of days ago, I came across a write-up by a colleague where he reported a research on people using AI for research writing. It was found that the parts of their brain responsible for cognitive functions was made inactive as a result of the use of AI when compared to those who do not use it.
That is true. That is very, very true. And when I say true, in terms of course, you if you are generating content that come from third party owners of sort of the content, you might need to actually study what the AI is bringing and sharing and wanting you to adopt and or adapt. But if the content is sort of created by you and kind of use AI to refine it, to advance it, that's probably a better way to use AI because the originality resides with you, the IP resides with you, and the innovation, the novelty of the work also resides with you. And of course, you can look at what others are doing, but not replace the innovation that should come from the researcher. How about grant writing? What are the pros and cons of using AI tools for grant writing?
Because of the sometimes inaccuracy in references, that can sell one out if you are using it for grant writing.
Okay. Yeah.
Then we also want to know, are you sure, is it expected, as in the people, most of those funders, you discover that some will actually put it that do not use AI. Then for some that they don't put it, is it ethical to use AI tools for grant writing?
Right. I would say depending on the funder's requirement, of course, the funders when they put this, what they call also eligibility, scope of the project, and they also provide some supporting information. And even most funders would actually have like a webinar to explain the grants. Now, depending on the project, if you are using AI to generate the proposal, and it's common. Now, the question would be, what information are you feeding to the AI to enable you meet the aim of the project and the objectives of the project? Okay. Because, see, for example, you are developing something for maybe you're applying for a grant to support a community of maybe disadvantaged people or vulnerable people or less privileged, and you actually need to work with them using co-production, So you are going to have to meet with the people to actually understand their needs. Okay. It is when you understand their needs, then you can solve their problem. But if you are trying to use AI, if the person is trying to use AI to solve a problem, without understanding the problem from the end users, those that will be benefiting from the problem, then that would be a big mistake in terms of getting funding for that project and implementing the project based on the outline objectives that will be presented by AI. So there is always the need to review whatever the AI is coming up with, if it's permitted to be used for grant writing in the context of the funders' remits and requirements. And most funders would probably not even bother about whether you're using AI or not, because they can check whether you've used AI.
Yes.
Yeah, funders can check whether you've used AI. And the challenge there would be where AI provides information that would deviate from probably the end, the objective, the scope, and probably impact logic model for that particular proposal. Because when one is designing a proposal, there would be a clear impact model, logic model from input, output to outcome. So the outcomes will be the impact of the output expected when the project is finished. And AI might not consider post-project sustainability. And in that case, it will be the place of the researcher to consider when this project finishes, what next? So, and these are areas that intelligent reviewers will use to also detect whether AI was used to generate this proposal. And if that is the case, then of course, such a proposal would not really sell because it's not fit for purpose. Does not pass quality assurance tests.
Thank you.
You're
So
welcome.
somebody already said that as well. He said most funders don't encourage AI use, as some use AI detectors to check submitted proposal. But he's also saying that I think it's okay to use AI to build ideas, but use human understanding to write.
Yeah.
Thank you. Yeah.
Sure. So you can use AI to sort of get you to start the ideation process. But remember, if the project involves engagement with the stakeholders, end users, obviously you need raw data. You need to hear from them. You need to find out from them. And of course, there's a way you represent the information that you've got from interacting with the community. Say, for example, you want a particular amount of money for a grant for NIWAD members or communities where people don't have access to maybe advanced equipment or mechanized farming kind of capability. So you might want to speak with the people, want to meet with them. So to tailor their needs or tailor the proposal to the local content or local needs. So make it relevant to the people. Because AI might not know who is going to use this proposal, the outcome or output of this proposal. So in that case, you definitely need to be very careful what information you want to get from AI or use AI to derive. Great. What are the practical AI platforms and sort of skills that we need? So there are AI platforms that are sort of made of integrated software infrastructure, and they are designed to facilitate the development, deployment, and management of AI applications. And these platforms are many, as we'll see shortly. Businesses use the platform to streamline their operations. They also enhance decision making. And there are AI developed or AI powered solutions that can be used internally and also externally. And when we look at some examples of AI platforms, we know the common Google Cloud AI platform, the Amazon SageMaker, Microsoft Azure, IBM Watson. We have Data Robots, Salesforce, Dialogflow. There are many other AI platforms that are available, and some of them are open source or free. Of course, others you need to subscribe. You might have free versions, but with limited capabilities. But there's always an opportunity or some resources online that you can leverage to start with. And I strongly encourage collaboration with international partners where you can bring something that they need and they can bring what you need in order to enhance your research, innovation, and development projects. Right. So I'll quickly just play this so we can have a quick Let me see if that will play, hopefully. Okay, can we?
To this presentation on AI in agriculture, where we're advancing smart farming with precision technology. My name is Andy, and I am currently a KTP associate at Manchester Metropolitan University, working with Dr. Sunday Ekpo. A little introduction to AI in agriculture. What is AI in agriculture? It's the use of machine learning, IoT, Internet of Things, drones, and robotics to optimize agricultural practices. Why does this practice matter? Well, at the moment, there's a global food shortage, and increasing efficiency and sustainability means we're going to reduce environmental impacts whilst increasing our agricultural yields. I'm going to start off with a project we have, which is the Smart Farming Precision Agriculture, using the SpressSense-enabled crop disease conditions and soil mechanics monitoring. This is the current project, which is one of the ones that we are doing at Manchester Metropolitan University, and the aims is to investigate wheat and leaf rust conditions using a SpressSense-enabled board and drone with 5G LTE NB IoT sensor connectivity, deployment, and operation. The objectives of this project is to integrate AI, and we're going to use convolutional neural networks with drones, which has cameras attached to it, to capture the image and do analysis on it. And we're also going to monitor environmental factors such as humidity, temperature, rainfall using IoT sensors. These soil nutritional level monitoring data, we can use random forests to predict the nutritional depletion and also recommend the strategies to actually compensate for this. We can analyze real-time sensor data on moisture and nutrient levels and make analytics based on this. And by using AI, we can make intelligent decision making. Okay, so a bit more about the convolutional neural networks used in our algorithm. We can see we have our image, and it's followed by this feature extraction layer with classification. And what we get in the output is whether the leaf, or in our case, the crop, is healthy, is it not healthy, does it have diseases? So you can imagine by training this model, we can identify if there's issues with just the drone. There's no human intervention required to be on the field. And how this works is these drones are equipped with the SpressSense microcontroller on board, which captures the high resolution images. These images are pre-processed locally on this board using a pre-trained neural network model, such as ResNet, and the severity can be classified into categories of low, moderate, or severe. Now, this AI algorithm that we have from our data, from this the IoT sensors such as humidity, moisture, rain, and temperature, we can use machine learning, for example, a random forest regression model, to predict the soil nutrition based on the environmental conditions. We can also have this integrated with our disease detection and inform us if there are diseases. And also, based on the humidity, moisture, rain, and temperature, we can use the algorithm to estimate the nutritional compensation required in real time, meaning we can turn on and off our water and nutritional irrigators. This requires less manual human intervention, and you can imagine the increase in efficiency. Another use case for AI in agriculture is optimal harvesting time. Imagine we have a drone which takes our raw images and applies photography to get these layers. And then we use the seeding detection and head segmentation which is your AI. And then we finally calculate the sizes of these crop yields. And by collecting the data over a period of, let's say, months and years, we can see when's the optimal time for harvest. So you can see when's the crop is at its largest size, whilst minimizing the amount of days we need to keep the crop growing. So at that point, you can get the optimal harvest date. And you can see it here. We've got our head diameter model. So the bigger the head diameter, the greater the crop yield. And this data can be fed in with the market data, and that would basically increase your harvesting time, but also your profit. And an example of how this would work was you could use something like a time series forecasting data with this kind of optimal harvest, and use neural networks to predict the best time to yield. This example is for the head size of broccoli, but this can also be applied to any other crops. Another similar example is market intelligence. You can predict market trends and optimize pricing strategy based on, let's say, the time of year, because different times of years would yield different market conditions and different crop yields. And by collecting a lot of data and feeding it into a predictive analysis using neural networks, we can kind of analyze the historical data, the weather and economic trends, and with this you can recommend pricing and marketing strategies to maximize the profit. One final use case I wanted to show is pollination optimization. There's recently been production of drones which is able to actually pollinize crops. And you would imagine these drones can be guided to mimic pollination patterns of bees. And this would enhance the crop pollination efficiency with our AI-guided drones. And these drones are able to target under-pollinated areas, which ensures full coverage. And this impact would be boosting pollination rates, yields, especially in the regions which have declining bee populace.
Right. So as we try to wrap up, I don't know if you've got any questions. Any questions?
Yes, sir. There are many questions.
All right.
So
okay.
maybe I can start from the most recent one. So somebody just sent now that sorry. Okay, so the person is asking, how can we adapt AI in aquaculture, especially in fish culture and fish pond management?
Great. There are so many ways we can adapt AI or integrate AI technology or AI innovation as an auxiliary technology and apply the techniques in aquaculture, like we talked about fish farming. So obviously, when you have the fish in the water, you will be expected to change the water, isn't it, over time? So if you install some cameras to monitor the changes in the water, changes that you might not be able to detect with your natural eyes. So high spectral cameras, hyperspectral, high pixel, very good cameras that can give you, in terms of spectral resolution, data you gather. So if you take a video or a snapshot, could just be image. Remember, there was the diagram I shared with us on the data set. So there was a diagram on the data set. So where you have tabular data, time series data, and then image or video. So with deep learning, because it's going to use different sort of multiple layers to analyze the data, it can actually get into the very fine details of whatever you're feeding into the AI model. And that would help you to make an intelligent decision in terms of changing the water at the right time where the health of the fish will be compromised if it is not done. So AI will definitely help to ensure that when it comes to intelligent decision making, it's not dependent upon probably what you observe physically, just with our eyes, human eyes, but based on the reality, the actual real-time situational awareness or situational kind of environmental condition of the fish. Because you can also detect the health of the fish based on the environment where the fish is, and that can help in taking the right decision. And you can automate the system. So if the system is automated, whatever image is fed into the camera, or the picture the camera is capturing, that can be fed into an automated system that can probably just empty the fish pond and fill it with fresh water for the fish without any human intervention. So, and that will be completely artificial intelligence driven and enabled. I don't know whether that helps, as it's just a tiny area of application. The other aspect might have to do with probably taking a sample of the water, and of course, you can do a test with that to determine probably the pH. So you can bury some IoT sensors that depending on the pH of the water, the sensor, remember the wireless communication connectivity, so there are underwater sensors. So when the pH of the water changes, the sensor will send data to the AI-enabled fish pond refilling, system. So that would automatically happen, whether it's camera or IoT sensor buried in the fish pond. Both will do the same thing, but they would probably use different data sets. So one might be using image, motion picture, or video. The other one might be using quantitative data, sort of like direct data capture from the sensor to make decision. But in the end, the intelligent decision would be to refill the pond with fresh water.
Thank you, sir. Please, there's a black, like a rectangular shape something covering some aspect of the slide. So I don't know if you can help us look into. Okay, thank you. I can see you're already going there. And for those asking if the video is available, in fact, we'll just share the link because the meeting is being live streamed. So somebody is asking, sir, that how can this AI applications how can it be fully utilized in the less developed countries? Then the second question the person is asking is aquaponics AI oriented? Thank you.
All right. So the first question has to do with opportunities and potential for the deployment of AI. Is that correct?
Yes. Yes, sir.
Great. So obviously, I would encourage collaboration, but there are also open AI tools, so kind of open source resources that one can use. So I would also encourage that to be the case. It's important to have infrastructure in place to fully deploy AI techniques and tools. And where such infrastructure, resources, or assets are not available, we can still do AI or can still implement AI, but there will be limitation as to what extent and the benefits, the dividends of the technology. It's driving global productivity. It's helping in accelerating probably ideation and innovations. However, you definitely need to work with other people such that you can complement and supplement the operations and the activities that we desire to use AI for, in terms of what you bring to the table, the other person brings to the table, especially if the technologies for AI are not available, say, in the global south. as opposed to what you have in the global north. And that's why we have opportunities for potential collaborations and partnerships in terms of grant writing and funding. And you can also have collaborations in terms of visiting research opportunities. So you do exchanges where you spend some time at a foreign university and get to know ways of implementing AI solutions in the work that you are doing. Yeah, I don't know what
Thank you.
Is that helpful?
Yes. Okay. Yes, but maybe a follow-up to that. I would like to ask that. Are you open to such collaborations?
Yeah, sure. In fact, we are actually working. We have some opportunities, I would say, that we will welcome collaborations from Africa. There is a project. Let me see if I can pull that up. Where you are all welcome to be part of. There is a project here that is called the. Can you see my screen, please?
Yes, we can. It's opening up. Okay. Yeah, good.
The Eco Sentinel project, and it's open to collaborations. So plan interaction, and we are part of this project, and we can help you be part of this project where you bring technology to the plants, and this can also incorporate AI. We can have AI as part of this as well. So we're open to collaboration.
Thank you. That's good. That's helpful. Thank you. Sorry, some people are also asking that, okay, there are conflicts arising from water and land pollution, which negatively impacts agriculture. How can AI be adapted in bioremediation to improve agriculture? Then maybe to add to that, somebody is also saying that, okay, you mentioned that AI can be used in the health sector. How can AI also help to mitigate, for example, to prevent climate change?
Right. So again, it depends on the parameters of I'll start with the last question. So we're talking about healthcare sector, we talk about climate change, talk about probably water pollution. It's important to note that when it comes to artificial intelligence, it's just a tool.
Yeah.
It's a tool that we use to solve problems. It's like somebody suffering from, say, malaria. If you stop the source of what causes the malaria in terms of the breeding place for the mosquito, then you don't need to think about trying to cure it. You know what I mean? So the thing here has to do with dealing with the problem in a very decisive way. It might even involve government policies as well. It might involve some influencers. But having said that, in terms of healthcare, we know that AI is currently being used in medical diagnosis, drug discovery, and personalized treatment plans. In environmental monitoring, let me say a classical example would be areas that are prone to either flooding or prone to other kinds of natural disasters. It could be earthquake, could be probably oil pollution, as the case may be. So what one could do is can buy some AI sensors that would be deployed in such an environment, and they will sense when these things are about to occur and probably communicate data that would help us make intelligent decisions. In that case, it could be that this area, probably somebody goes to a place that is polluted with hydrocarbons. So if you have a sensor there, we can detect the fumes in the air. And the AI sensor can advise that the fumes in the air that I'm sensing is going to lead to cancer or lung disease. It's not good to stay in this environment for maybe 2 hours or 1 hour. 5 hours. If a person actually went there to probably work, if it was a farm, or maybe went there to do some other type of manual jobs. So there are AI tools that can be used to actually help us operate within different environments safely and healthily. So those tools can be deployed. They are also available on our mobile phones or some apps, but we can have external sensors that we can integrate into our mobile phones with apps to help us make intelligent decisions when it comes to environmental challenges. Yeah.
Thank you.
You're welcome.
So somebody is just, thank you. So for people asking about fish and water related, so somebody, I think Dr. Teresa Dokubo is saying that in the farm where I manage in rivers, we had sensors, water quality sensors in the pond that monitored water quality, sending readings to all stakeholders wherever they were in the world. So that shows that yes, all these things are possible.
Absolutely.
So somebody is asking, sir, that what is the clear difference between application of IoTs and AI in research, since there seems to be the same garbage in and garbage out process? Do you get the question, sir?
Yeah, I do. Now,
yes,
AI is a tool that enables intelligence to be derived from the data that we collect. Internet of Things, I would say, has to do with the visible and the invisible assets. So visible asset would be like your mobile phone connected to the internet. That is an Internet of Things device. Your laptop, if it's connected to the internet, it's an Internet of Things device. If your home is connected to the internet in terms of home automation, if your car has a Bluetooth, that is an Internet of Things. So Internet of Things is not really limited to small devices with low power consumption. Internet of Things can be big, can be small. The key thing there is they must have the capability to send data across the global network. Now, that a device sends data through the network doesn't mean the device is intelligent. The intelligence comes when decisions are made based on some premises. And in that case, if data is fed into the device and the device has the resources, including AI modules or AI platforms that it can use to make an intelligent decision, and either inform the user or the user will take the decision or take the information from the AI and then interpret the information whether to act on it or to leave it. So AI is not the same as IoT. IoT needs AI to be smart. Does that make sense? So when we say intelligent IoTs, so something makes the IoT to be intelligent. Internet of Things, IoT means Internet of Things, devices or sensors. When we build in some algorithms, AI models into that device, could be your wristwatch, monitoring probably, blood pressure. Once that happens, the intelligence there can be sent remotely to the doctor, and it can also inform the person that based on your temperature, you should have rest, or based on your temperature, or based on the color of the hemoglobin passing through, you are likely, that person is likely to have one challenge or the other. And medically, you should see the doctor, the person should see the doctor or the GP, as the case may be. So these are things that would enable intelligent outcomes to be realized.
Thank you. Yeah, thank you, sir.
Can exist without the AI, but the AI definitely will need the Internet of Things device to gather data for intelligent decision making.
Thank you.
You're welcome.
So another question says, what are the key limitations in using machine learning?
Right. So we've sort of touched on it before. Again, when we talk about machine learning, if you recall, I think one of the slides that I shared had to do with, I think, what's this slide maybe? So if you look at machine learning, a key limitation probably, I mean, there are many, but a key limitation I would always say is the quality of the data. I would always want to start with what comes in, because you cannot give what you don't have. So whatever the data it was trained with, okay, classical example would be, assuming we use AI to develop a new drug, and the data that was used for the AI to discover the drug was data based on people living in Europe and not in Africa. Do you think that drug will be effective globally?
No.
Exactly.
Can't.
So that is why you don't just buy anything and swallow, because it must have been developed based on a different population. So, and that is definitely, so what is good for another person can become a poison to another population. So limitation in terms of the quality, because the AI cannot know that the data used to train the model. It cannot change it to suit another population or population data set. It cannot do that. It doesn't have that. Even the generative AI depends on existing data. So that is why there's a need to keep updating the data sets. The larger the data set, the better. You know, and of course the computational overhead when it comes to actually using advanced models is also another challenge. So nowadays we have tiny machine learning, which could enable some intelligent decisions that are smart, but very, very low power, ultra low power kind of implementation, especially at the edge, what we call edge AI.
Thank you.
You're welcome.
Thank you, sir. Yeah, so somebody is also asking that, in your own opinion, do you really think AI will take over our jobs?
I would say AI will challenge us to learn new things. Because what happens is, when we say take over our jobs, well, probably they will take over some jobs, but if you've got work, AI cannot take over your work.
I love that.
Because job has description, no job description, but work is not job. We say work. You have work to do. AI cannot think for you. AI actually depends on us to think. So the AI will challenge people to upskill, especially in terms of digital technology. Of course, wherever you have influence, especially those in the academia, I would encourage us to integrate AI into our curricula, so that AI is not going to be like a discipline. AI is an auxiliary tool. So it's not, okay, this person goes to study AI. No, even if you're a lawyer, even if you are an agriculturalist, you are a teacher, you've got to learn AI. It becomes like a tool. So it's not something that somebody needs to go and study as a degree before you can make it. No. And it's been so simplified that even if you've got no knowledge about how to code or program, you can use the tools. At least that is the good thing about AI models, AI techniques, because it's made to be inclusive.
Thank you, sir.
You're welcome.
That's very interesting. Very interesting. Please, the black box has returned. So somebody is saying, please, can you help I remove it?
Okay.
Then, yes. Then somebody is also asking that there is increasing cyber threat. How much can AI do to curb this? What can AI do? How much can AI do to curb cyber threat?
Yeah, I think one of the presentations I'm not sure where that was, but let me see. I know one of the presentations I did talk about aspects of AI helping in taking care of cybersecurity issues. So if you look at the screen, cybersecurity, AI can be used to detect and prevent cyber attacks, and that would result in the protection of systems and data. Because we don't know what goes on online in the day, in the night, provided it's connected. And of course, not many people turn off their internet. The mobile phone, laptops, desktops, devices that are connected to internet, like cameras, security cameras and home sensors, washing machine, whatever you got, and is connected to the internet. Anything that connects to the internet is prone to cybersecurity threats. So the AI can help to detect those threats because they'll be trained. But of course, AI will be limited if new threats emerge that they were not trained to detect. So you can now see where human intelligence still comes in. So probably you don't visit sites that you ought not to visit. You don't click on links that you're not sure of. Somebody sends a link and tells you click it. No, you don't click it. Now, if that link contains threats that the AI model that has been deployed on that device you're using, could be a new mobile phone with advanced cybersecurity features, the very fact that that phone has been produced, as soon as it is produced and commissioned for use, deployed, that phone automatically becomes obsolete. Because following its production and deployment and use, probably new cybersecurity threat emerged that the manufacturers or the AI developers did not consider. But it's good that we have apps that can also be deployed or installed. We call firmware. We can update. So that's why we have updates. So we can constantly be updating our devices with new firmware or third-party products that are secure and safe. And that would help to protect our devices. So updates, very important, though that would come at a cost in terms of memory usage. Because the more threats that come out to affect the devices, the more the manufacturers will send and advise updates in the background. And those updates will need storage space. And that could eventually make the device to be obsolete. You need a new device with better memory and storage space.
That's good. Thank you, sir.
You're welcome.
So we are gradually rounding off, everyone. So somebody also wants to know, she's asking that what are some of the ethical, social, and legal aspects raised by the worldwide adoption of AI applications?
Yeah. Currently, I am part of the AI ethics, IEEE AI ethics working group. And I would say a key thing that has to do with AI or what we are developing a standard, a global standard that will be used around AI ethics. Because obviously AI does not think, does not have the consciousness to think. And AI does not have the emotion that we have as humans in the context of being able to be causal, So AI depends on whatever was programmed into it in that context, the data that it was sort of trained with. So ethically, many organizations, especially professional and technical bodies, are working to ensure that AI, depending on the type of AI that's being deployed, even up to generative AI, they are sort of working to ensure that wherever AI is deployed, the aspect of social inclusion is accommodated. So classical example could be a particular AI or organization using AI for recruitment, and the AI is developed or designed to maybe isolate certain population from getting the job if it's used for recruitment, or is used for the selection process by the company. So in that case, that would be wrong. So there are policies, regulations, and laws that have been put in place, of principles, ethical AI ethics, principles that have been developed and also gradually being rolled out globally for corporate organizations and NGOs, um, industries, both commercial, uh, also, of course, the educational systems across the world, individuals as applicable, businesses. So as they deploy these AI tools to enhance productivity, to accelerate, their the efficiency of their processes and their systems, their organizations, they also expected to adhere to some AI ethics that are crucial, especially when it will disadvantage a certain population.
Thank you, sir. I can see some questions around cost implications. And somebody asking, what is the cost implication of using AI technology in fish farming, crop production, and things like that?
I would say it depends on it depends on the scale of what you want to deploy. Obviously, as I mentioned before, there are cameras you can buy and they are very cheap. They are not costly. There are sensors you can buy and deploy in your fish pond or wherever you got your plants or crops or animals deployed, and they are not costly. I think the scale of what you want to do would come into play here. And there are some open AI platforms you can use online. Of course, there are others that you need to subscribe to. You need to pay either monthly or annual fees. But you can always improvise something to enable you derive some intelligence to inform your decision making and enhance your productivity. So it's definitely possible. You can always, especially in the modern world, today's world, open source platforms are available, open AI resources are available, which you can actually deploy at a scale that suits your budget. So if you need help with that, our team can help you in that. You feel free to get in touch. If we understand the problem, we understand exactly what you need to do. You might actually deploy AI at no cost, apart from the cost of maybe getting some sensors to install.
Thank you. That's good.
You're
That's
welcome.
helpful, sir. Very well. Thank you.
You're welcome.
Yeah. So let me just read these comments. We only have a question left. But before I read the question, the last question, somebody said factual truths. Using AI, one must have done the real work. AI will just assist, but without the real work, there will be confusion. So the person is saying yes, in terms of the data inputs, in terms of what you are putting in. We have always known it. Technology is garbage in, garbage out.
Sure.
If garbage nonsense in, there's no way it can make sense of the
You cannot
nonsense.
give what you don't have.
That absolutely. Thank you, sir. Yeah. So the last question says, how does robotics contribute to the intersection with AI? And people are also requesting for your email address. I think we can share that. I believe this person is a member of NEWORD, so we'll share that with everyone. So how does robotics contribute to the intersection with AI? Thank you, sir.
Right. Thank you very much. Before the advent of probably modern AI had been existing, because even with robotics engineering, robotics technology obviously is older than AI. AI is just playing on the technology, on the data. If you have a robot that moves around in a community or in an environment, and the robot has sensors, the sensors are expected to gather data from the environment. They are expected to process the data either on site, so on site meaning on the robot. When we go out, we see things. We process the data immediately as we are divinely coded to do, and we take a decision. Say, oh, call that child. That place is dangerous. Oh, pick that thing, and because somebody can step on it. Now, if you send an AI to go into an environment to monitor the environment, probably there are broken bottles, and the AI is not programmed with intelligence to know that broken bottles can be stepped on, and it can be dangerous if somebody steps on those broken bottles. The AI will see the broken bottles, might just report, but will not do anything about it. Or if it was programmed to pick those broken, glasses or whatever, the AI finds that could be dangerous and lethal, then that is the intelligence. That is where the AI is helping the robotics to make an intelligent decision based on what the robot observes. So AI enables the robot to have intelligence, just like AI supports humans to make intelligent decisions. Of course, robots are non-human. Robots are just machines that help humans to do tasks that could affect the health of humans over time.
Thank you so very much, sir. Thank you.
You're welcome.
And everybody is also saying a very big thank you for this that you have helped with today. Thank you for providing clarification on, some of the misconceptions about this subject of discussion. We appreciate you so well. Thank you for your time. And thank you for also extending your arms of association and collaboration to us all. We appreciate you, and we are sure that you get to hear from us in due course.
Sure.
I would also like to appreciate everyone for joining, everyone for participating, everyone for contributing. Thank you for giving your time and your resources, because for you to have used data to join the session, it shows you are really committed to learning and improvement. Thank you, everyone. So from NIWAT, we like to appreciate everyone. Yeah, and we also like to say that you should expect more of this, more webinars, more development, more seminars, more workshops that will help us in our various researches and in our various work. Yeah. So thank you, everyone. We have come to the end of the presentation today. We appreciate you, sir. Everybody is saying thank you. Thank you
very much. Thank you.
Yeah.
It's my pleasure. Thank you.
Yeah.
Thank you.
Thank you.
Bye-bye.
Yeah.
Thank you, Doctor.
Thank you. Bye-bye.
God bless you. Thank you, sir.
Thank you very much.
Bye.
Bye. Bye.
Bye-bye, everybody. Thank you for attending.
Thank you. Yeah. Oh, yeah, sorry. Yeah.